All right, today we're doing something really cool. We're not just going to solve a problem, we're actually cracking a code. I'm talking about the language the entire universe is written in. So let's dive right in.
You ever look at a page of math and just feel your eyes glaze over? It can feel like you're trying to read some kind of secret code, right? Just a jumble of mysterious symbols and lines. It's like, where's the decoder ring for this stuff?
Well, here's the thing. It's not a secret code at all. It's a language, and it's one of the most powerful and universal languages out there. And just like any other language, once you get the basics down, this whole new world just clicks into place. So let's learn how to read it together.
Okay, so where do you start with any language? The alphabet, of course. And in math, our alphabet is all about quantity. These are the absolute basics, the symbols for counting and calculating.
And here they are. You know these guys, right? Plus, minus, times, divide. Think of these as the verbs of math. They're the action words. They tell us what to do with the numbers. Everything, and I mean everything, is built on these four.
Now this little guy, the equal sign, it's so much more than just the button you press on a calculator to get the answer. It's a powerful statement of fact. It's basically shouting, hey, the stuff on this side is exactly the same as the stuff on that side. It's all about balance. All right, so we can say when things are the same. But what about when they're not? That's where we get into the grammar of math, how we describe the relationships between all these numbers.
Okay, greater than and less than. These two are basically mirror images of each other. The classic trick, and it always works, is to think of it like a hungry alligator's mouth. It always wants to eat the bigger number. So you can see how 5 is greater than 3, and 3 is less than 5 are really just two ways of saying the exact same thing.
And check this out. See how we just add a little line underneath? That's basically part of an equal sign. And just like that, the meaning gets an upgrade. Now it's not just greater than, it's greater than or equal to. It adds this new layer, this little bit of maybe, that makes our math sentences way more flexible.
You know, the real world is messy. Things aren't always perfectly exact, and math has a symbol for that. This wavy equal sign means almost equal to or approximately equal to. It's for when close enough is good enough, which, let's be honest, is pretty often in real life.
So, we've got the basics for talking about numbers. But what if we want to talk about whole groups of things? This is where we level up, moving from simple sentences to organizing big collections of ideas.
Let's walk through this. First, just imagine any collection of stuff. That's a set. It could be a set of your favorite songs or a set of numbers. Then you have a single object. That's an element. So the big question is, how do we write down in math language that a certain song is in your playlist?
And this is the symbol for it. It kind of looks like a curvy letter E, which makes it super easy to remember. E for element. So if you see this symbol, you can just read it as is an element of. Simple as that. Suddenly, you're not just looking at symbols. You're actually reading a sentence.
And look, there's that pattern again. You just draw a line through it, and it means the exact opposite is not an element of. This is a super common trick in math. A slash almost always just means not. It's super efficient, right?
Okay, now we can start doing things with these groups. The union symbol, which looks like a U for union conveniently, is like combining two playlists. You just dump everything into one big list. The intersection symbol finds only what the two playlists have in common. You know, the songs that are on both of them. It's a way to combine and compare whole groups of things.
Okay, we've got the alphabet, we've got some grammar. Now it's time for the poetry. These are the symbols that let us talk about the really big, mind-bending ideas, the stuff that's almost too big for words alone.
Infinity. This one's a biggie. It's not actually a number, you can't count to it. It's a concept. The idea of something that just goes on and on and on forever. This one symbol manages to capture that whole mind-blowing idea of endlessness.
And speaking of going on forever, take a look at this number. It just keeps going. And the crazy part, the pattern never ever repeats. A number this important, this fundamental, obviously needs its own special symbol.
And that symbol is pi. That little Greek letter is basically a nickname for that infinitely long number we just saw. It's the magic number that connects the circle's circumference to its diameter, and it pops up in the most unexpected places all across science. This big, pointy E is the Greek letter sigma, and it's basically a command. It means add 'em all up. It's a super handy shortcut, so you don't have to write out, 1 plus 2 plus 3 plus all the way to 100. You just use this symbol to say, sum it all up. It's the language of finding the total.
So, if sigma is for adding up a bunch of separate things,
What do you do when something is continuous, like the flow of water or the area under a curve? For that, you need this, the integral. You can think of it as adding up an infinite number of infinitely tiny pieces. This is a huge, huge deal in calculus. The universe is all about change, right? Nothing ever stays the same. And this little triangle, delta, is the symbol for that. It just means the change in something, the change in price, the change in your location, the change in temperature. It's how math talks about a world that's always in motion.
So think about it. We went all the way from a simple plus sign to the symbol for the integral, from basic, everyday counting to the literal poetry of the cosmos. These aren't just random squiggles on a page. They are the words and the grammar of a language that can describe our reality with incredible accuracy.
The point is, it's not a secret code anymore. You now know the fundamentals. You can read the basics of this universal language. So the only question I have for you is, now that you can read it, what are you going to use it to discover?